All right, let's get right into it. We are living in a world that is basically run by models. Seriously, from the financial markets to climate science to how we build a bridge, all of these complex systems help us try to predict the future and make these huge society-shaping decisions. But how do we know we can actually trust them? That's exactly what we're going to unpack here. Because, well, when we get it wrong, the consequences are massive. In 1998, you had this huge hedge fund, long-term capital management, that just imploded because its models got some basic assumptions wrong about how markets move together. A decade later, poorly tested models for mortgage-backed securities helped crater the entire global economy. And then in 2012, a single bad model cost JP Morgan Chase almost $6 billion. See, these aren't just abstract problems for academics. This stuff has real world-shaking impact.
So how in the world do we avoid these kinds of disasters? Well, it turns out we can boil down this whole complicated process of building trust into two beautifully simple questions. First, are we building the model right? And second, are we building the right model? Now, they sound almost identical, I know, but the tiny difference between them, well, that's everything.
Okay, let's tackle that first question. Are we building the model right? This is all about looking inward, getting into the guts, the nuts and bolts of the model itself. And this brings us to our first really important term, verification. And I found a fantastic, super clear definition for this from the engineering community over on Reddit. They say verification is just the process of checking that you are solving the equations correctly. It's purely an internal check. Does my code actually do what I told it to do? Is the math adding up properly? That's really the heart of it. Verification is that meticulous, sometimes, let's be honest, tedious work of debugging your code and double-checking your math. It has absolutely nothing to do with the real world yet. It's just about making sure the machine you've built is working exactly according to its own blueprint. And what's really cool is that this idea isn't just for engineers or coders. Turns out, over in research psychology, they have a name for the exact same concept. They call it internal validity. It's the same fundamental idea. Did you set up your experiment in a way that you know for sure the results you're seeing are because of the thing you're testing and not some other random hidden factor? It's all about that internal, logical soundness. So once you've verified that your model is built correctly, that all the nuts and bolts are tight, now you have to ask that second, much bigger question. Are we building the right model? This is where we finally have to connect our perfect little creation to messy reality. And this, of course, brings us to our second key term, validation. And let's go back to that great Reddit source. If verification is solving the equations correctly, then validation is about making sure you're solving the correct equations in the first place. It asks the big question, does this elegant piece of math and code I've built actually mean anything in the real physical world?
This is the absolute crucial point. Validation is your reality check. It's where you take your model's predictions and you smash them up against actual real-world data. If your financial model says a stock is going to go up, you check it against what the stock actually did. If your engineering model predicts a bridge will hold a certain weight, you've got to go test it in the real world.
And yep, you guessed it, just like before, there's a perfect parallel in the world of research. It's called external validity. And this idea asks how well the results of one little study can be generalized to other people, in other places, at other times. It's the same exact question as model validation. Does this thing I found actually work outside of my perfect, controlled little lab? Okay, so let's just put this all together in a nice, simple framework. On one side, you've got verification, and its cousin, internal validity. They both ask the same thing, are we building the model right? And their focus is totally on internal logic. Then, on the other side, you have validation and external validity. They ask, are we building the right model? And their focus is on connecting to real-world reality. You absolutely need both to have a model you can even begin to trust. But, and this is a huge but, even if you do all of that perfectly, there is a deeper, sneakier danger lurking right under the surface. It's what researchers call model form uncertainty. And this is where things can get really interesting and honestly pretty dangerous. I mean, just stop and think about this for a second. What if your code is absolutely perfect, totally verified, and what if its predictions perfectly match all the historical data you have? It's totally validated. But what if the entire structure, the core idea your model is built on, is just flat out wrong? There's this quote from a research paper that just says it all perfectly. No amount or quality of data can overcome a structural inadequacy in the model. In other words, if your foundation is cracked, it doesn't matter how pretty the house is that you build on top of it. The whole thing is compromised from the start. So let's make this really concrete. Just look at this graph. The black dots, that's the real world. That's reality. And you can clearly see there's a curve to it, right? But our model was built on the hidden assumption that the relationship should be a straight line. That purple shaded area, the model's prediction, you can see it's desperately trying to fit a straight line onto that curved data. It's verified, the math is right, it's even kind of validated for the data we have. But the core idea is just wrong. And here is the terrifying result. Look at those sharp purple peaks. That shows the model has become extremely confident about its answer, but it's the wrong answer. A confidently wrong model is 1,000 times more dangerous than a model that knows it's uncertain. Okay, so now that we know all this, how can we think more critically about the models that are shaping our lives? Let's put together a simple toolkit for trust that you can use. It really just boils down to 3 steps. Step 1, verify the process. You got to ask, is it built right? Check the logic, check the code. Step 2, validate against reality. Ask, does it actually match the real world? Test it with real data. And then the most important step of all, step 3, question the assumptions. Ask, what are the hidden foundational beliefs this whole thing is resting on? And what if they're wrong? Because at the end of the day, the most powerful question you can ask about any complex system is the one that everyone else just takes for granted. It's the assumption that's so deep and so obvious that nobody even thinks to question it in the first place. And that leads us to our final question for you. In this world that we live in, a world being built and run on this vast foundation of models, what are the critical, hidden assumptions that we as a society might be forgetting to check? The answer to that? Well, it could define our entire future.